Hello, hi everyone. Hi everyone, welcome to the Student the Brand. This is our Sva sir. Now we are going to discuss about electric current. Electric current, CBSE Grade 10 Physics. Okay, so CBSE Grade 10 Physics, electric current we are discussing now. First of all, what is current? The rate of flow of charge is called electric current. So the flow of charge is moving in the conductor. Then only we can say current is flowing. So when charge is moving in the conductor, then we can say current is flowing. That is I equal to Q by T. I equal to Q by T. So here I equal to Q by T. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. And SI unit of time is second. Okay. So SI unit of current is ampere. So here you can see. So why you are writing small letters and here you are writing coulomb. Okay. So the SI unit of time is second. SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross sectional area per second. So that is 1 ampere equal to 1 coulomb per 1 second. 1 ampere of current. 1 ampere is defined as 1 coulomb of charge flowing through 1 ampere of current is defined as 1 coulomb of charge is flowing through the conductor per second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross sectional area per second is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Yes. So I have one question. Will you say only one electron flows? Will you say only one electron flows in the conductor? Will you say current is flowing? Only 2 electrons flows. Will you say current is flowing? Only 3 electrons flows. Will you say current is flowing? We can't say only 1 electron, only 2 electrons, only 3 electrons, only 4 electrons flows. We can't say current is flowing. Then number of charges are moving in the conductor, number of charges are flowing in the conductor, then only we can say current is flowing. Then only we can say current is flowing. Q equal to quantization of charge. Q equal to quantization of charge, that is equal to plus or minus any. Sir, why you are saying plus or minus any? Why you are saying plus or minus any? So plus or minus any is nothing but positive charges and negative charges. So negative charges are represent electrons, positive charge represent protons. Okay, so that's why they're saying plus or minus Ne. Okay, so plus or minus Ne. So I already mentioned in earlier classes, so in so many times I mentioned. So right now, so I'm taking live class from Hyderabad. Okay, I hope it is very clear. Understood? So now number of charges are moving in the conductor, then only we can say current is flowing. Q equal to plus or minus Ne. N is the number of charges on one electron. So here positive charges are there, negative charges are there, positive charges are negative charges. Positive charge, negative charge, positive charge, negative charge, positive charge. Understood? On one electron, on one electron, on one electron. On one electron, how much charge is present? 1.6 into 1.6 into 10 power minus 19 coulomb. On one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb present. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? So you can see, you can take 1 coulomb 1 by 1.6 into 10 power minus 19. Then if it is goes 1.6 into 10 power 19, then you know 1 by 1.6. 1 by 1.6. 1 by 1.6. 0.625. 0.625. Yes. In 1 coulomb, 0.625 into 10 power 19 coulomb. So if you are removing one zero, you can remove and separate. Then 6.25 into 10 power 18 electrons. That is 1 coulomb. 6.25 into 10 power 18 electrons are present. 10 power 18 electrons. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. 1 ampere is defined as 1 coulomb of charge is flowing through unit cross-section area per second. 1 ampere. Yes. Okay. On 1 electron, how much charge is present? On 1 electron, how much charge is present? On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Understood? So this is about electric current. Do you know why you are saying quantization of charge? 1 electron flows, we can't say current is flowing. Only 2 electrons flows, we can't say current is flowing. Only 3 electrons flows, we can't say current is flowing. Then how many electrons flows we can say current is flowing? Number of charges. Number of electron flows only, then we can say current is flowing. Yes, so those are positive charges are there, negative charges are there. Positive charges are there and negative charges. Positive charges are protons, negative charges are electrons. Positive charges are protons, negative charges are electrons. Those charges are moving in the conductor. Those charges are moving in the conductor. Right? Yes or no? Charges are moving in the conductor. Then only we can say current is flowing. Then only we can say current is flowing. Yes or no? If number of charges, that is called quantization of charge. Q equal to plus or minus Ne. Q equal to plus or minus Ne. Quantization of charge. On one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 6.25 into 10 power 18 electrons are present. So this is about electric current. This is about electric current and quantization of charge. And in 1 coulomb, how many electrons are present? On 1 electron, how much charge is present? These are the points. Now, electrical elements. What are those? What are those electrical elements? Now we'll discuss about it. First one is cell. First one is electrical cell. That is one positive terminal, another one is negative terminal. Coming to the battery. This is the battery. Positive terminal, negative terminal, positive terminal, negative terminal, cell, battery. Next one, third one is open switch. This is the open switch. Open switch. Open switch. Open switch and closed switch. Open switch and closed switch. Right? Yes. So that the fourth one is closed switch. Closed switch. And coming to the fifth one, resistor. Resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomenon of opposing the electric current. Resistor, resistance. And ohm, SI unit of resistance is ohm. SI unit of resistance is ohm. Resistor. So you can observe this is the resistor. Resistor. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. So this is the resistor. And the next one, sixth one, rheostat. This is the rheostat. Understood? So this is the rheostat. So what is the use of rheostat? Rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. That is called rheostat. This is a rheostat. And coming to the ammeter. Ammeter is a device which is used to measure the current in the circuit. Ammeter is a device which is used to measure the electric current in the circuit. Okay, so positive terminal, negative terminal. Coming to that, voltmeter is a device. Positive terminal, negative terminal. Voltmeter is a device which is used to measure the potential difference. Ammeter is a device which is used to measure the current in the circuit that is connected in series combination. Coming to voltmeter, voltmeter is a device. Voltmeter is a device which is used to measure the potential difference, that is connected in parallel combination. So here I am connecting voltmeter, ammeter, wire joining. This is a wire joining. 10th one is wire crossing. 11th one is bulb. This is a bulb. Okay, so this is a bulb. Cell, battery, open switch, closed switch, resistor, rheostat, okay, rheostat, and ammeter, voltmeter. Ammeter is used to measure the current. Voltmeter is used to measure the potential difference. Okay, so if the current is passing in the circuit, okay, so ammeter must be connected in series. Okay, so ammeter has fixed reading, it measures the current. Coming to voltmeter, it measures the potential difference. If you connect voltmeter in series combination, it will not show any reading because some difference must be there. In series combination, no difference. Same current will go. That's why ammeter is used to measure current that is connected in series combination to the circuit. Coming to voltmeter, voltmeter is a device which is used to measure the potential difference that is connected in parallel combination. Voltmeter is a device which is used to measure the potential difference that will be connected in parallel combination. Okay. Next, so wire joining, wire crossing, and ammeter and resistor. Resistor is a device. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device, but resistance is the phenomena of opposing the electric current. And rheostat, which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. I hope it is very clear. Next one. Next one is so electrical circuit. Understood? So let's start electrical circuit. Electrical circuit. Okay. A closed and a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. So here you can see electric circuit. Electric circuit. Okay. So here this the bulb. So ammeter. So this the battery. Switch. So current is passing like this. Positive terminal, negative terminal. So bulb is glowing because switch is closed. Current is passing. So you know one thing, there are two types of current. One is One is conventional current and electric current. One is conventional current, another one is electric current. Now, what is conventional current? Conventional current is nothing but the flow of positive charges. Conventional current. Conventional current. Second one is electric current. Electric current. Electric current. So conventional current is nothing but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal. Positive charges are moving from positive terminal to negative terminal. Positive terminal to negative terminal. Whereas electrons are moving from negative terminal to positive terminal. Negative terminal to positive terminal. Yes or no? Conventional current is nothing but the flow of positive charges. Electric current is nothing but the flow of electrons. Flow of electrons. Yes. Understood? So here you can observe conventional current. So high potential to low potential. High potential to low potential. Positive charges. Positive charges are moving from positive terminal to negative terminal. Yes or no? Positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Negative terminal to positive terminal. Conventional current is nothing but flow of positive charges. Electric current is nothing but flow of electrons. Now you can observe. Now you can observe one thing. So conventional current moves like this. Electrons will move opposite. So now you can understand. Now you can understand. Conventional current moves like this. Electrons moves like this. So both are moving opposite direction. Both are moving opposite direction. Positive charges, negative charges. Positive charges, negative charges are moving opposite to each other. Sir, why you are saying like this? Okay. So, in the magnetic effects of electric current, electrons will move like this. You have to take current direction like this. Electrons will move like this. So, you have to take current direction like this. Electrons move like this. You have to take current direction like this. So, you have to take electric current direction opposite to electrons movement. That is the conventional current. What is that? Conventional current. What is it? What is it? Conventional current. What about electric current? Electrons will move from negative terminal to positive terminal. Electrons will move from negative terminal to positive terminal. Positive charges will move from positive terminal to negative terminal. Ah. Understood? Dishka. 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 Yes. So negative charges, positive charges. Negative charges, positive charges. Yes. Understood? And electrons will move from low potential to high potential. Electrons will move from low potential to high potential. But positive charges will move high potential to low potential. So one more questions they will ask. Will electrons move from low potential to high potential or high potential to low potential? Confirm. Electrons will move from low potential to high potential. Electrons will move from low potential to high potential. High potential. Positive charges will move from high potential to low potential. Yes. So here you can see electric current low potential to high potential. Low potential to high potential. I hope it is very clear, right? Yes. So positive charges are moving from positive terminal to negative terminal. Electrons are moving from negative terminal to positive terminal. Conventional current, electric current. So now we will discuss about potential difference and electrical potential. Yeah, a potential difference and electrical potential. Why? What is going on? What you are discussing next? I am discussing about potential difference. After that, electrical potential. What topic now we are discussing? Potential difference. What is that? Potential difference. Potential difference. Okay, so potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor. Huh? Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. So I am taking the conductor is here. This is A and this is B. So this is a positive charge. We are doing work. We are doing work. Yes, we are doing work to bring unit positive charge from one point to another point within the conductor. That is called potential difference. V equal to W by Q. What is the SI unit of potential difference? Volt. What is the SI unit of work is Joule. What is the SI unit of charge is Coulomb. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point. That is called potential difference. So V equal to W by Q. V equal to W by Q. Yes. So SI unit of potential is volt. SI unit of work is joule. SI unit of charge is coulomb. 1 volt is defined as 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point within the conductor. That is called potential difference. Coming to electrical potential. Electrical potential. Electrical potential. Work done to bring unit positive charge. Work done to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. So here this is the positive charge. This is at infinity. This is our required field. This is our required field. This is our required field. We are doing work We are doing work. This is our required field. This is our required field. We are doing work to bring positive charge from infinity to the required field. From infinity to the required field. That is called electrical potential. V equal to W by Q. V equal to W by Q. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. That is called potential difference. Potential difference. Understood? Potential difference and electrical potential. Now we will discuss about Ohm's law. Oh my God. Ohm's law. Oh. Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I and V equal to IR. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Yes, V equal to IR. Yes or no? V equal to IR. Right? Yes. So now we'll see. So now we can see V equal to IR. So what are the metals required? We'll discuss now. So what are the metals required? We'll discuss now. So let's start. So what are the metals required? What are the metals required? So how to do the activity? And what is a procedure? What is a circuit diagram? What is graph? And what is a tabular column? Oh my God. Ohm's law, Ohm's law. So definition, materials required, circuit diagram, procedure, tabular column, graph. We have to discuss all these points, right? Yes, the potential difference. Again, come to the points. Here you can see the Ohm's law. Ohm's law activity, Ohm's law. Ohm's law equal to yes or no? So V is directly proportional to I. V equal to IR. V is directly proportional to I. V is directly proportional to I. V equal to IR. V equal to IR. Understood? Materials required. What are the materials required? Materials required. Materials required. First one is, so what are the materials required? First one is 4 cells. 4 cells. Those are 4 cells among this one. 1.5 volts of each. 4 cells. 1.5 volts of each. Yes, 4 cells. Here 4 cells. 4 cells. 1.5 volts of each. And coming to the second one, nichrome wire. Nichrome wire is an alloy of nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Understood? Nichrome wire is an alloy of nickel, chromium, manganese. So nichrome wire is 0.5 meter length. And coming to the third one, ammeter. And coming to the fourth one, voltmeter. And coming to the fifth one, switch. And coming to sixth one is connecting wires. Understood? So once again, 4 cells, 1.5 volts of each, nichrome wire 0.5 meter length, ammeter, voltmeter, switch, connecting wires. So what is circuit diagram? Circuit diagram. Yes, now we will discuss about circuit diagram. You have to connect all the cells to the series combination to the ammeter and resistor. After that, we have to connect cell. All these elements must be connected in series combination. All must be connected in series combination. Understood? So just take once here. Series combination. So 1, 2, 3, 4. 1, 2, 3, 4. 4 cells. Understood? 1 I am taking, 2 I am taking, 3 I am taking. Here, ammeter, next one resistor. This is the resistor connected to voltmeter. Resistor is across the resistor, I connected voltmeter. Oh my god. Across the resistor, I connected voltmeter. Oh my gosh. Why? Because voltmeter is used to measure the potential difference, no? Yeah, we have to connect in parallel combination to the circuit. My god, voltmeter is connected in parallel combination. Why? We have to connect. Compulsory. What is the reason? What's the reason? Why we are connecting? Voltmeter in parallel combination? Because to measure the potential difference. Why you are connecting ammeter in series combination? To measure the current. That's why I am connecting here. So positive term, negative term, positive term, negative. So now you can observe. So this is switch. What is this one? Switch. Understood or not? So current is passing like this. Yes or no? Current is passing. So I am connecting cells. So here we are connecting first 1 cell and 2 cell, 3 cell and coming to 4 cell. Sir, why you are connecting with the dotted line, sir? Sir, why you are connecting with the dotted line, sir? Why can't you connect with the normal lines? Because from one cell, first you have to connect one cell. And you have to connect to 2 cells. After that 3 cells. After that 4 cells. First you have to connect one cell. And you note down the reading of ammeter and voltmeter. Then you connect to 2 cells. After that you can connect and repeat with 3 and 4. So here you can see 1, 2, 3, 4. We are drawing with the dotted lines. Yes, sir? We are drawing with the dotted lines. That's why. That is the reason why we are drawing with the dotted line. Because first you have to connect one cell and note down the reading of ammeter and voltmeter. After that you have to connect to 2 cells and note down the reading of ammeter and voltmeter. Then onwards you have to repeat the process for 3 and 4. Repeat the process for 3 and 4. Then observe the reading of ammeter and voltmeter. What is ammeter reading? Current. What is the voltmeter reading? Potential difference. So this is the resistor, 0.5 meter length, 4 cells, 1, 2, 3, 4. So each cell potential is 1.5 volts, right? So these are the materials. Circuit diagram. This is circuit diagram. And coming to the next one, tabular column. So this is the tabular column. Serial number of cells, ammeter reading, voltmeter reading, V by form. Serial number 1, 2, 3. So serial number of cells, ammeter reading, voltmeter reading, V by form, that is R. So 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. First you have to connect one cell, then note down the reading of ammeter and voltmeter. Then connect to two cells and note down the reading of ammeter and voltmeter. Then repeat the process for 3 and 4. Then you have to observe the values. Those values you must write in the tabular column. Those values, whatever you observe, those values, that must be written in this tabular column. Then you have to do one thing. What is that? What is that? You have to draw the graph for VA. You have to draw the graph for VA. The graph is V on y-axis, I on x-axis. The graph is linear. The graph is linear starting from origin. It represents straight line. That means V is directly proportional to I. V is directly proportional to I. V is directly proportional to I. So if you draw the graph for non-ohmic conductors, for ohmic conductors the graph is straight line. For non-ohmic conductors the graph is curve. Oh, sir. What is ohmic conductor, sir? Sir, what is ohmic conductor, sir? Ohmic conductor is nothing but the conductors which obey Ohm's law. The conductor which obey Ohm's law, those are called ohmic conductors. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. That's enough. Non-ohmic conductors. If it is not following Ohm's law, that's enough. If it is follows Ohm's law, that is called ohmic conductor. If does not follow ohmic conductor, those are called non-ohmic conductor. Non-ohmic conductors. That's enough. I hope it is very clear, right? Yes. Now, so I'll discuss about resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Resistance and resistivity. Okay? Resistivity. So the phenomena of opposing the electric current is called the phenomena of opposing the electric current in the circuit is called resistance. Resistor is the device which is used to oppose the electric current. Resistor and resistivity. So resistance, this is a resistance because the phenomena. Resistivity is equal to resistance of the conductor per unit length and unit cross-sectional area. So you can see R is directly proportional to L, R is inversely proportional to area of the cross-section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross-section. Yes, R is directly proportional to L. R is inversely proportional to A. R equal to L by A. R equal to rho into L by A. So resistance. So here you can observe resistivity equal to RA by L. Resistivity equal to RA by L. Resistivity is equal to resistance of the conductor per unit length and unit cross-sectional area. R by L into A, or RA by L. That is called resistivity. Yes. So here SI unit of resistivity is very important. Ohm meter square by meter. Meter get cancel. Ohm meter is the answer. What a rhyming. Meter get cancel. Ohm meter is the SI unit. Waha. Okay. So resistance depends on temperature. Resistance depends on nature of the material. Nature of the material. Understood or not? Resistance is depends on temperature. Resistance depends on nature of the material. Now resistivity is also depends on temperature, and resistivity also depends on nature of the material. Nature of the material. I hope it is very clear. Understood? So these are the differences between resistance and resistivity. Once again, check here. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. Okay. So R is directly proportional to L by R equal to rho into L by R. Resistance depends on temperature. Resistance depends on nature of the material. Resistivity rho equal to RA by L. Resistivity rho equal to RA by L. SI unit of resistance is meter. SI unit of area is meter square by meter. Meter get cancel. Meter get cancel. Rho equal to ohm meter. So resistance depends on temperature. Resistance depends on nature of the material. Understood? So next we'll discuss about resistors are connected in series combination. Then resistors are connected in parallel combination. Resistors are connected in series combination. Then resistors are connected in parallel combination. So here 1, 2, 3. So here R1, R2, R3. Across R1 I am connecting V1. Across R2 I am connecting V2. Across R3 I am connecting V3. So ammeter current is passing here. So this is the battery switch. So now you can see. So switch is closed, current is passing, positive terminal, negative terminal. Then positive, negative, positive, negative, positive, negative, current is flowing. So in the circuit, in the circuit, current is same because all resistors are connected in series combination. So all resistors are connected in series combination. Series combination. So that's why IS equal to I1 equal to I2 equal to I3 equal to I. So but potential difference is different. So from Ohm's law, V equal to IR, Vs equal to V1 plus V2 plus V3. That is nothing but IRS equal to IR1 plus IR2 plus IR3. So I am writing. So I am taking I common. I you can take common. On both sides. I is common. No, you can take I common outside. And you can cancel on both sides. Then you will get. So IRS equal to I are taking common R1 plus R2 plus R3. So I get cancel RS equal to R1 plus R2 plus R3. If n number of resistors are connected in, if n number of resistors are connected in series combination, then RS equal to NR. Understood? If n number of resistors are connected in series combination, R is equal to NR. Understood? I hope it is very clear. Next one. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Resistors are connected in parallel combination. Then what happens? We'll see now. Resistors connected in parallel combination. 1. Next one 2. Next one 3. So that is connected in parallel combination. Ammeter. So here you can observe, here you can observe, here you can observe. So switch. Now that is connected here, current is passing here. Understood? So you can see. This is R1, R2, R3. R1, R2, R3. Okay. So that is connected. That is connected. So here you can observe that is connected here. This is connected here. V. Like this. So current is passing. So through R1 I1, through R2 I2, through R3 I3. Okay. So now you can observe here. Now you can observe. Understood? Now you can observe. So that is potential difference is same. What is that? Potential difference is same. So V P equal to V1 equal to V2 equal to V3 equal to V. But current is different. Current is different. So that is IP equal to I1 plus I2 plus I3. That is V by, from Ohm's law, V equal to IR. I equal to V by R. Then V by RP. So V by R1 plus V by R2 plus V by R3. That is, now you will get. So we am taking common. So 1 by Rp equal to, we am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So we get cancel. So if n number of resistors are connected in parallel combination, so n number of resistors are connected in parallel combination, so that is 1 by Rp equal to N by R, Rp equal to R by N. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. I hope it is very clear, right? So resistors are connected in parallel combination. So now we will discuss about heating effect of electric current. Heating effect of electric current. Let's start heating effect of electric current. Heating effect of electric current. V is directly proportional to V equal to W by Q, W equal to V into Q. So we know Q by T is I, right? What is that? So P equal to W by T, V into Q by T, that is I, P equal to VI. So energy is given to the conductor equal to P into T. Equal to P into T. H equal to VI into T. So we know V equal to IR. V equal to IR from Ohm's law. From Ohm's law, V equal to IR. Understood or not? From Ohm's law, V equal to IR. So that's why we are taking H equal to IR into I into T. Then you'll get IR into I into T, then you will get I square RT. H equal to I square RT. So this is about heating effect of electric current and also known as Joule's law of heating. Heating effect of electric current and also known as Joule's law of heating. I hope it is very clear. Understood? So this is about electric current CBSE grade 10 physics. If you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. Inform your all your friends, ask them to join to the class. Okay, so if you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. So just subscribe and share a word to your friends. So share a word regarding the channel to everyone. So thank you so much for joining. Thank you so much for supporting. So Santosh, so thank you so much for supporting and so encouraging the channel and keeping your effort towards the channel. So thank you so much. We'll see you in the next class. So thank you everyone. So remaining with your names. So in the name of everyone, thank you so much for joining and attending and listening my class. So thank you so much. So I'm hoping. So we'll see. So with our support, I can reach to the heights. So thank you so much. We'll see in the next class.